Ever looked up at the dawn sky and seen that brilliant, unwavering light? That's Venus, our dazzling morning star. It's the brightest object up there after the sun and moon. But have you ever noticed that some mornings it seems to shine just a little bit brighter, and other times it's a bit dimmer? You're not imagining things. This isn't just about its distance from Earth. Something strange is happening high up in Venus's atmosphere, and it's a mystery that has astronomers scratching their heads. For decades, we've known that Venus's glow isn't constant. It varies, sometimes significantly, over periods of days, months, and even years. You might think it's a planet, not a star, so its light is just reflected sunlight, right? Exactly, and that's where the puzzle begins. The amount of sunlight Venus reflects depends on its thick, swirling clouds of sulfuric acid. So, a change in brightness must mean a change in the clouds. Astronomers have a couple of leading theories. The first idea is all about cloud chemistry. They suspect that a mysterious, unknown chemical in the upper atmosphere is absorbing ultraviolet light from the sun. If the concentration of this unknown absorber changes, it would directly affect how much light gets reflected back to us, causing the planet to appear brighter or dimmer. Think of it like a planetary scale mood ring, its color and brightness shifting based on its chemical makeup. Scientists are trying to figure out what this substance could be and what causes its levels to fluctuate. The other major theory involves massive atmospheric waves, similar to the waves you see in our oceans, but on a colossal, planetary scale. These are called planetary scale waves, and they ripple through Venus's super-rotating atmosphere, which spins 60 times faster than the planet itself. These powerful waves could be stirring up the cloud layers, changing their thickness and structure. Imagine huge, slow-motion ripples in the clouds, altering how they reflect sunlight moment by moment, day by day. This could explain the shorter-term variations we observe in Venus's brightness. The problem is, neither theory perfectly explains everything we see. The chemical model struggles to account for the rapid changes, while the wave model doesn't fully explain the long-term trends. Some scientists now believe the answer might be a combination of both, a complex dance between atmospheric chemistry and powerful waves. It's a fascinating puzzle. Venus, our closest planetary neighbor, still holds so many secrets. Solving this mystery won't just tell us about Venus. It will help us better understand the atmospheres of planets everywhere, including our own. So next time you spot that beautiful morning star, remember the dynamic, mysterious world hiding behind that brilliant glow. Thanks so much for watching. If you enjoyed this cosmic mystery, don't forget to hit that like button and subscribe for more space explorations. See you next time.